0.4, and this is a block, let us say of mass 4 kg, and a external flow force is applied on this block, which is equal to, say, 12 Newton. Then what is the acceleration of the block? Find limiting friction and acceleration of the block. Okay. So what do you mean by limiting friction?
Sir, can we do the problem, sir?
Ah, limiting friction is the maximum value of static friction. Limiting friction is the maximum value of static friction. Static friction is that friction which acts between two bodies which are at rest when one body tries to move over the other. Maximum value of that static friction is limiting friction. So limiting friction is
16 I got, sir.
Fs max, which is mu s into n. Mu, let us say, if nothing is mentioned, we'll take the friction which is given in the question. Okay, or I will say, okay, let us take mu s is 0.4 for this surface, and mu k, kinetic friction, is 0.3. So to calculate limiting friction, you should take quotient of static friction, which is 0.4, into normal reaction. Normal reaction is equal to mg. 4g acts downward, normal action is this. So normal action is equal to 4g, 0.4 into 4 into g10. So 4, 16. 16 Newton is the maximum value of static friction. Okay.
Sir, I got retardation, sir. -1 meter per second.
How can we get retardation? Will due to this friction, will the block move in this direction?
Oh, okay, sir. No.
So here the point is, applied force is less than limiting friction. Applied force 12 Newton is less than limiting friction, as the applied force is less than limiting friction. The block does not move. Therefore, acceleration of the block is 0. Acceleration of the block is 0. And in this situation, if I ask you, what is the value of friction? What is the value of friction? The magnitude of friction on the block is how much? 16 Newton? 12 Newton. 12 Newton, because the block is not moving. That means this applied force 12 Newton should be balanced by friction force. So friction should also be 12 Newton. Friction is also 12 Newton. Okay. Next. Coefficient of friction 0.5. Block of mass 10 kg. External force applied is 150 Newton. Find acceleration of find friction on the block. Okay, or limiting friction. Number 2, acceleration of the block. I will give again two values. This mu s static friction is 0.5 quotient and kinetic friction is 0.3. Okay. Now, limiting friction. Maximum value of static friction, which is mu s into n. Mu s is 0.5. Normal reaction is weight. So 10 into 10. 5 into 10, 50. 50 Newton is the limiting friction. Okay. How is the applied force? How much is applied force? 150. Applied force is greater than limiting friction, as applied force is greater than limiting friction. The body will be accelerated. The body will be accelerated. How much is the acceleration? Acceleration is net force by mass. Net force by mass. How much is net force? If you look at the 10 kg block, 150 Newton is acting towards right, and friction here, which friction? Kinetic friction is acting towards left. When the block starts to move, static friction disappears and kinetic friction comes into action. So kinetic friction will be active during acceleration of the block. So what will be the net force? Net force is applied force minus friction force divided by mass. Applied force 150. How much is this kinetic friction? Kinetic friction is not 15 Newton. 15 Newton is static friction. Kinetic friction will be mu k into m. Mu k into m. Okay. So F minus mu k. How much is mu k? 0.3 into normal reaction mg. Mass is 10. G is 10. Divided by this applied force is 150. Divided by mass 10. So acceleration is 150 minus 30 divided by 10. 120 divided by 10. 12 meter per second square is the acceleration. 12 meter per second square is the acceleration of the block. Next, situation is like this. This is a block of mass 4 kg. Tied with a string running over a pulley. And to the other end of the string, another block of mass 10 kg is suspended. And this is a rough surface with coefficient of friction 0.2. Then question is, find acceleration of the system and tension in string. Tension in string. We have done this type of question previously without considering friction. Same question now, including friction. Okay. So for acceleration, what formula did I tell you for acceleration? What
MS. Sir, F minus Fk divided by.
net pulling force divided by total mass. Wherever you find connected bodies, which are in direct contact or which are connected through strings or which are running over pulleys, wherever you see connected bodies, to find acceleration of the system, you should use net pulling force by total mass. Very, very important formula. Now, what is the net pulling force? If you look here, what is the net pulling force? The weight of this 10 kg block, 10g, is pulling the system down. The weight of this 4 kg block, 4g, is balanced by the normal reaction, m. There is friction. If this block tries to slide towards right due to weight of 10 kg block or due to tension in the string, friction acts on the block. In which direction? In this direction. Friction acts on the block. Okay. Then net pulling force is 10g minus friction. 10g minus friction by total mass, 10 plus 4, 14. 10g is 100 minus friction is mu n. Friction is mu n divided by 14. So 100 minus mu, how much mu? 0.2. 0.2 into normal reaction is how much? 4g. That means 40. Normal reaction is 40 divided by 14. So acceleration is 100 minus how much? 8 by 14. 92 by 14 meter per second square. This is the acceleration. Then what about tension in the string? Tension in the string. What should we do to write tension, to find tension? We should draw FBD, free body diagram. Of which block? You can take any block. I'll take 10 kg block. FBD of 10 kg block. Its weight 10g acting downward. Tension in the string T acting upward. And the system is getting accelerated A downward. Then if I apply F net equal to MA, what is the net force? 10g minus tension is equal to 10A. Acceleration we have got it here, 92 by 14. So 10g, 10 into 10, 100 minus t is equal to 10 into 92 by 14. From this you get t is equal to 100 minus, first of all, 100 minus 920 by 14. How much is this value? 1400 minus 920 by 14. 1400 minus 920. 480 by 14. 480 by 14. How much?
40.
40?
No, sir.
No. You'll get 30 something. Do that.
Sir, 35, sir.
35 Newton.
Sir, 34.2 we got, sir.
Oh, so this is the tension. This is the acceleration. Procedure is same. The only difference is while writing the net pulling force, you should include friction also. If you see coefficient of friction mentioned in the question, you should include friction also. Next, another question. We have a incline of 30-degree angle. This is a rough incline. Coefficient of friction is 0.2. And on this incline, we are releasing a block of mass 4 kg. Of mass 4 kg. Let us say we are releasing it from rest. Then what will be the acceleration of the block? Find the acceleration of the block. Right. What happens here? See. What are the different forces acting on the 4 kg block? Its weight 4g is acting vertically downward. Okay. To understand the motion of this block, we should take components of this weight. Components of this weight. What are the components? One component will be along the incline. Another component will be perpendicular to the incline. If this angle is theta, this angle will be theta. Then this will be 4g cos theta. This will be 4g sin theta. Okay. Then other than this, normal reaction. Normal reaction. Yes. Then if the block tries to slide down, friction acts because this is a rough incline. In which direction? Down the incline or up the incline?
Up the incline.
This is the direction of friction. So 4g sin theta along the incline, 4g cos theta perpendicular to the incline, normal reaction perpendicular to the incline, friction along the incline. These are the four forces acting on the block. Now, acceleration of the block is net pulling force, same formula. Net pulling force by total mass. Okay. What is the net pulling force here? 4g sin theta is trying to pull it down. Friction is trying to
So,
pull it
what
up.
is handed minus frictions?
4g sin theta minus friction will be the net pulling force divided by mass m.
4.
Okay. 4g sin theta, 4g 40, sin theta sin 30 minus friction. How much is friction? Friction is mu n. Friction is mu n. Okay. So 40 sin 30, sin 30 is 1 by 2. So 40 by 2, 20 minus mu is 0.2.
8.
Normal reaction. How much is normal reaction? How much is normal reaction? Normal reaction is equal to 4g cos theta. Normal reaction is equal to 4g cos theta because 4g cos theta is perpendicular to the incline, which is balancing the normal reaction. So you cannot write normal reaction equal to mg here. Normal reaction will be mg when the block is on horizontal surface. mg normal reaction, both will be same if the block is on horizontal surface, but this is on incline. On incline, only a component of weight will be acting perpendicular to the incline. not total weight. So n is not equal to mg, it is equal to mg cos theta or 4g cos theta here divided by m. Okay, now substitute the values. 20 minus mu is 0.2 into 4 into 10 into root 3 by 2. Cos that is root 3 by 2 divided by what is the mass? 4. How can you simplify this? 20 minus 8 into root 3 by 2. 4 root 3. 4 root 3 divided by 4. Acceleration 20 minus 4 root 3. Root 3, what is the value of root 3? 1.732. Standard value, you should remember this. Root 3 is 1.732. Root 2 is 1.414. We will be coming across these two values frequently. So 1.732 into 4, how much?
So 3.528.
3.528. I will make it 3.53 divided by 4. 20 minus 3.53.
Sir, 16.47.
16.47. I will make it 16.5 by 4, which is approximately 4
4.
meter per second square. So this is the acceleration. Right? If the same question is asked without mentioning mu, then what will be the acceleration of the block? If friction is ignored, or in the absence of friction, acceleration is equal to
Net pulling force by mass, sir.
net pulling force by total mass.
We can add pulling force, sir. There's no net here.
What is the net pulling force? Only mg sin theta divided by mass m. Mass cancel. G sin theta, which is 10 into sin 30, which is 1 by 2, 5 meter per second. So if there were no friction, the block would have come down with acceleration 5. But because of friction, it is coming down with only 4. Because friction is trying to oppose the motion of the body. Okay, like this, you can include friction in any situation. Okay, this is about friction, a very important kind of force. Right. And I think, yeah, this in one way, this completes laws of motion. Laws of motion chapter. We have covered all the basic concepts and basic models of questions that can be asked. Okay. Then after this, what do we have as per our schedule? We have work, energy, power. Next chapter is work, energy, and power.
Sir, these chapters, according to what there is this order, sir.
This order is as per your NCERT class 11.
Okay, sir.
So it will be different. It will be little bit different from the 9th class one, right?
Yeah, different. It is different from your class 9. We
Sir, just a second.
we are discussing the concepts of these chapters at class 11th level. Okay.
Sir, could you start in a new page, sir? It's becoming difficult to view the notes in future, sir.
Okay, right.
Thank you, sir.
Work energy power. So students who have completed their class 9 would have studied this, and those who are entering into class 9 now will be studying this in your regular, whether it is your state board the syllabus or CBSE syllabus, you have this chapter in your class 9. The same chapter, it will be there in your class 11. And in class 11, it is a very important chapter. It has a lot of weightage, lot of very important concepts will be coming across in that chapter, work energy power. We'll try to understand this in fundamental level. Work energy power. Okay. As the title of the chapter itself says, we will be discussing these three concepts. What is work, what is energy, what is power. Right. First one, work. Work is a very common term that we use in our day-to-day usage, right? You will be hearing, what does your father do? If they intend to say, what work does your father do? Okay, or I am busy with my work. In such situations, we will be using this term work. But the meaning of work in our daily life and the meaning of work in physics, they are entirely different from each other. Suppose if I say that a software engineer is working from home, work from home concept. It has become common nowadays after lockdown. So work from home. So what will he or she will be doing? They will be sitting in front of the laptop and doing some programming, coding, all these things. Okay. In our regular sense, they are doing work. They are doing work. Or if a farmer is doing agriculture in the field, he is doing work. Or if a student is sitting and studying or reading or writing, then he or she is doing work. We treat all these things as works in our day-to-day life. But as per physics, work is a different thing. It has got a different description, different definition. As per physics, we say that work is done. Who can do work in physics? Who in day-to-day life? Who can do work? A software engineer can do work. A student can do work. A farmer can do work. Okay, or a labor can do work. Any individual can do work. But in physics, work can be done only by a force. Work can be done not by bodies. Work cannot be done by bodies in physics. Work can be done only by forces. That force can be gravitational force. That force can be friction force. That force can be tension. That force can be this weight, or that force can be your spring force. Any force can do work. Okay, and that too, it's not just like a force acts on a body and work is done. For work to be done in physics, the condition is, let us say this, we have a body like this, and on this body of some mass m, on this body we are applying a force F. External force F is applied on the body. Due to this force, the body gets displaced. It gets accelerated and it starts to move. If it moves, it will get displaced. It will get displaced. Let's say after some time, it is here. The body is here. Okay. This is a displacement of the body. Yes. Displacement, yes. Then work is defined as the product of force and displacement. Work is defined as the product of force and displacement. Or in simple way, we say that work is done only when a force acts on a body and displaces it. Work is done when a force acts on a body and displaces the body. Okay. So work, technically its definition is, work is the product of, or As we have studied
Can-
vectors, we have studied vectors. In vectors, we got two types of multiplications, products. One is dot product, other is cross product.
Cross.
Scalar product or vector product. What kind of, here force is a vector quantity. Displacement is also a vector quantity. So what kind of product is do we take between these two? We take dot product. So work is the dot product. Work is the dot product of force and displacement. Force and displacement. If I write it mathematically, work is equal to F dot S. F dot S. F dot S. What is F dot S? Fs
Force speed displacement.
cos theta. F dot S is Fs cos theta. F cross S is Fs sin theta. We are talking about dot product here, so it is F dot S equal to Fs cos theta. F is force, S is displacement, theta is angle. Angle between what and what? Theta is the angle between what and what? Force vector and displacement vector. Do you remember or not? Vector product.
Yes, sir.
P dot Q was PQ cos theta. Theta was angle between P and Q. If you take two vectors like this is vector P, this is vector Q, making angle theta with each other. Then their dot product will be P dot Q is equal to PQ cos theta.
Sir,
Hmm.
sir, in most cases, it will be perpendicular to each other, right?
Depends. It can be perpendicular. It can be along the direction of force. It can be opposite to the direction of force. Depending, depending on that, we get three types of works. So work is Fs cos theta. Okay. Now force will be having some fixed magnitude. Displacement some fixed magnitude. Theta can be different. Angle between force and displacement can be different in different situations. If theta lies between 0 and 90 degree, value of theta lies between 0 and 90 degree, less than 0 less than or equal to theta, and theta less than 90 degree. That means if the value lies in first quadrant, then what is the value of cos theta? Cos theta is positive.
1, sir.
For 0, it is 1. Let us say
Oh.
30 degree, it is root 3 by 2. 45 degree, 1 by root 2. 60 degree, 1 by 2. Like that, up to less than 90 degree, you will have the value of cos theta as positive. It can be 1 by root 2, it can be root 3 by 2, it can be 1 by 2. Then
Zero.
you will get a positive value. Okay, cos theta is positive. Therefore, work force, there is no meaning for negative force. Force cannot be negative. Displacement also cannot be negative physically. You might get negative sign, but that means opposite displacement. Okay. So force is positive, displacement positive, cos theta is positive. Then work is positive. Work is positive. Work is positive. Second, if theta is equal to 90 degree,
So 0.
or I will take this case first. If 180 less than or equal to theta, so not 90 degree less than theta less than or equal to 180 degree. That means this is second quadrant. In second quadrant, cos theta is negative. Negative. That means work done is negative. Work done is negative. Next, if theta is exactly 90 degree,
Sir, 0, sir.
then cos 90 is 0. Cos theta equal to 0. Therefore, work done is also 0. So we get these three possibilities for work done. That means work done in physics can be positive, negative, or 0. This is quite different from the notion of our work in day-to-day life. In day-to-day life, nobody does negative work or nobody does 0 work. Okay, or positive, negative work in day-to-day life are meaningless. But in physics, we have a completely different definition of work. In physics, we say work is done on a body by a force only when the body is displaced by the force. Only when the body is displaced by some force should act on a body and the body should get displaced. Then we say that work is done by that force on that body. And this work done can be positive, negative, or 0, depending on what? Depending on the angle. Angle between what and what? Force and displacement. So if I put all these things, these three cases in simple words, we can write it like, if force and displacement are in same direction, work done is positive. Work done is positive. Force and displacement same direction. Example, this is a block.
Sir, pushing an object.
Oh, this is a block. Suppose you are pushing this block. So what is the direction in which you are applying force? This direction.
The board same direction.
What is the direction of displacement of the block? This direction, towards right. Both force and displacement are in same direction. Then the work done by you is positive. Work done by you is positive. Next, if force and displacement are opposite to each other, then work done is negative. Work done is negative. Force and displacement are opposite. How can force and displacement be opposite?
So when we are pulling an object,
I'll take the same example of pushing the block. The same block. You are pushing the block. You are applying force in this direction. The block is getting displaced in the same direction, but friction is acting on the block. In which direction? In this direction. This is the direction of friction, and this is the direction of displacement. How are friction and displacement opposite to each other? So work done by friction in this case is negative. Work done by friction is negative because it is opposite to displacement. Whereas in the same situation, work done by applied force is positive.
Sir, can't friction be 0, sir? Friction.
If
So
friction is
works.
0, work done by friction will be 0.
Sir, if it's
No,
not 0, is there any chance for 0, sir?
if friction is 0 means surface is smooth. If there is no friction, work cannot be done by friction.
Okay.
So point to be understood from this example is, in the same situation, more than one force might be doing work on the same object. More than one force might be doing work on the same object. This block is the same, on the same block, same body. Force applied by you is trying to do work, trying to displace the block. friction is also trying to do work. So you should read the question carefully. What work done by whom is asked? This is an important question. Work done by whom? You should identify this first while solving questions related to work done. Because in the same situation, more than works might be done by more than one force. Whose work is to be calculated in the question? That is to be first identified. So in the same, I can ask two questions on this example. Find work done by man. Find work done by friction. Work done by man is positive, you get some value. Work done by friction, you get some value, but that is negative. So this is an important point in work done. Work done by whom? Which agent, which force is to be calculated? Next. Or let us take one more example. Suppose there is a block on ground. Okay. Now what you do is you lift that block. You lift that block and hold it above your head like this. Right? A block was on the ground. You lifted that block and you are holding it on your, you lifted it above the ground. Okay. In this situation, what is the work done by you? Positive, negative, what is the work done? To lift the block, in which direction did you apply the force? In this direction.
Upward.
Upward. And what is the direction of displacement of the block? Upward.
Sir, this is not
Upward.
Displacement is also in upward direction. So force and displacement are both in same direction. So work done by man is positive. How much? It's a different thing. We'll come to that later. Work done is positive.
work done by gravity is negative, sir.
In the same situation, another force is also doing work. Which force? Gravity. Gravity is trying to pull the block down due to its weight mg, but the displacement is upward. Yes. So force and displacement are in opposite direction. That means work done by gravity is negative. Work done by gravity is negative. So again, same situation, two forces are acting. One force applied by you to lift the block, another force gravity trying to pull the block down, or its weight, in other words. Like this, you should identify work done by which force is asked in the question. Okay. Then if force and displacement are perpendicular to each other, then work done is 0. First case was force and displacement in same direction. Then work done will be positive. Force and displacement are opposite. Work done is negative. Force and displacement are perpendicular. Work done will be 0. Example. We'll take the same example. Suppose you lifted this block, placed it on your head, and you are walking. You are holding this block over your head and you are walking. Okay. You are walking means displacement of the block is in this direction. Okay. Then what is the direction of force to lift the block, to hold it above your head? You should apply force on the block. In which direction? In this direction. How is force and displacement? Perpendicular to each other. Theta is 90 degree. Cos 90 is 0. So in this case, work done by man is 0. Even if you walk for walk holding that block over your head for 1 meter, 10 meter, or even 10 kilometer also, work done by you will be zero. But if you think in terms of work done, normal meaning of work in our day-to-day life, you will be doing a lot of work. You will get tired. You will be losing energy if you walk holding a block over your head, right? But as per physics, you are doing zero work. That's the difference between work in regular usage and work in physics. In this situation, work done is zero. And gravity is acting down. Gravity, weight mg is acting down, which is again perpendicular to the displacement. So here, work done by gravity is also zero. Work done by gravity is also zero. So this is what you should understand regarding work. First of all, definition of work: product of force and displacement, that to dot product, Fs cos theta. Depending on the value of theta, work can be positive, negative, or zero. If force and displacement are same direction, work is positive. Force and displacement are opposite, work is negative. Force and displacement are perpendicular, work is zero. Basic things. Then we can have different situations to calculate work done, depending on. See, calculating work done is very easy. You should identify what force is responsible or what force is doing work and what is the displacement of the body and what is the direction between these two. If you understand these three factors, what force, how much displacement, what is the angle between force and displacement, F, S, theta. If you could identify these three things, then you can do any question related to work. Very simple. Okay, we'll do questions based on this work in the next class. Then we will see how work is related to energy, what are the types of energies, law of conservation of energy, then how work and energy are related to power. We will see these things in the coming classes. We'll continue this in our next class. Okay, right. So see you and good night.
You can give some example, right?
Good evening, sir.